Today we'll be starting Unit 2, and you should have already previewed the two websites that I shared with you, so you should have a general understanding of what exactly a radian is and how we're going to be measuring angles. Just to recap and kind of get some terminology at the forefront of our brains, we're going to start by defining an angle, and you'll see here that I've typed in the definition. It's determined by rotating a ray about its endpoint. So off to the side here, I have this little blue ray that we're going to be talking about rotating clockwise as well as counterclockwise. So maybe the angle stops here, or maybe the angle rotates all the way over here. But what we're talking about is this angle measure, or conversely, we could be talking about this angle today. Now, angles in standard position is important here. Note that for all of the rotating that I did, I am measuring off of the positive x-axis side. So if we look at the picture here, the initial side would be what I've circled in green, whereas the terminal side is what I'm going to circle again in the blue. So the terminal side is where the angle is going to end. We already discovered that there's two different types of rotation. If we're rotating counterclockwise, we consider that to be a positive angle. That's what you've worked with all your lives thus far. And if we're talking about negative angles, then we're actually rotating clockwise. So we're going to, and the way I remember this is that we're rotating clockwise, so we have to go down from the x-axis in a negative direction, versus if we head upwards from the positive x-axis, that's going to be a positive direction. Now, again, we already know that two ways to measure angles are either degrees, which is what we've used so far. The other option is this radians concept. And if you did read those websites, you learned that degrees are actually kind of the thing that was man-made in a way. So somebody decided that a circle had 360 degrees in it, so a degree is equivalent to 1/360th of a complete rotation about a vertex. So if we take a circle and divide it into 360 equal parts, that's what a degree is. So whatever that measurement might be. Obviously, we can use protractors to measure in degrees. Whereas a radian, the focus again is more on length instead of the degree or the angle opening at the center of the circle. So for this, you saw in the website that they drew a circle with center, and then maybe we have the radius marked here and here. Well, the measure of angle theta is equal to the arc length, which we'll refer to as S. So theta equals 1 radian if the radius is equal to the arc length at that opening. So if theta opens up to the length of the radius across the circle, then that's considered to be 1 radian. Now, a couple additional notes here. And again, you probably already learned this. 1 revolution is equal to not 3600. It changed my degree symbol to a 0. That should be 360 degrees, or 2 pi radians. So just like circumference is 2 pi r, 2 pi is a full revolution. And then a half a revolution, if we cut that in half, again, this is the degree mark, not a 0, 180 degrees, or pi radians. And we can continue to make those kind of fractional cuts to determine radians in versions of pi. We also note that radians are typically, for us, going to be using pi, but it's also possible to have like 2.34 radians. It doesn't always have to be in terms of pi. So let's take a look at a couple examples where we're going to sketch. We're going to start with the angle negative 540 degrees. So why don't you try pausing the video? Again, I want you to be drawing angles in standard position. So you're going to start at that positive x-axis and then rotate negative 540 degrees. Go ahead. So the thing to keep in mind is that we're rotating in negative direction. So I know that I'm going to be headed downward. So I'm going to start over here and I'm going to rotate around this way in a clockwise direction. For this particular angle, I know that it's greater than a full revolution. So I'm going to just draw a circle 1 full length. So there's negative 360 degrees, but I can't stop there. 540 is exactly 180 degrees higher than 360. So I'm just going to extend this arc mark to the x-axis on the negative side, and then I'm looking at this particular angle. So 360 degrees plus 180, we're rotating in a negative direction to get negative 540. Let's take a look at an example in radians. So again, we'll sketch out our xy axis, and this time I would like you to pause the video and try plotting 2 pi over 3 radians. So go ahead. Note here this time that we are going to be rotating in a positive direction, so we want to rotate up or counterclockwise. And if we add a couple marks to our diagram, so if the angle was only the positive x-axis, it didn't lift off, it would be 0 degrees or 0 radians. We know that half of a rotation is pi radians. And then if we come back around, because we can go bigger than 2 pi and keep going, like we saw in the first example, we'd be back to 2 pi. Now, if you just look at the fraction, we're looking at 2/3 of pi. Well, if I kind of divide up my quadrants, or the top half of the coordinate plane, I would say a third is probably about here, another third here, and I've got 3/3, or a total of pi, across that top first and second quadrant. So 2/3 pi radians would be to that second mark here. And again, these are sketches, so they don't have to be perfect. We are just approximating where these angles are going to lie, but they should be close, right? I'm not going to make this angle super close to the x-axis because it should be closer to the y-axis than the x. And then the last one we're going to practice sketching is negative pi over 4. So again, try pausing the video and drawing that on your own, and then come back to double check. So first thing I would do is, again, start to kind of divide up. So obviously, again, here is 0. If we're rotating in a negative direction, as we rotate on the underside, so rotating this way, right, this direction will get us to negative pi. So if I come back here, that means half of pi would fall at the negative y-axis, or negative pi over 2. Well, pi over 4 is half of pi over 2, so the angle I want is halfway between 0 and negative pi over 2. We're going to draw in that negative direction, and I'm going to add onto the sketch here that this is negative pi over 4. And then on the other angles, in this one, I'll just circle that. But as on the terminal side, it'd be helpful if we put what the actual measurement is there. So when you're sketching, again, try to be as accurate as possible without like using some type of tool. And secondly, you want to make sure that you're drawing in that directional rotation so that we know whether you're rotating positive or negative. Now, one of the things that we are going to need to do is to be able to convert between degrees and radians, and then back and forth from radians to degrees. So first formula that we're going to get is going from degrees to radians. We're going to take the number of degrees and multiply by pi over 180. And why do we do that? Well, pi over 180 are the same measurement. So it's pi radians over 180 degrees. Well, they're the same angle. The other thing to note is that this is degrees over degrees, so the degrees cancel out, and we're left with radians as our final answer. So that's going to equal radians. So let's do an example of that first. So I want you to convert 135 degrees to radians. So what we'll do is we'll take 135 times pi over 180. And in this case, you should be able to do this without a calculator. You're just simplifying fractions, so you can reduce the 135 and the 180. Perhaps you see that they're both divisible by 5, or maybe you see a bigger number. But when you're all said and done simplifying completely, you should get 3 pi over 4, because the pi is just going to stay in our answer. Whether you choose to include radians in your final answer or not is up to you, because, take a look up here, when no units of measurement are specified, if we're talking about angles, radians is implied. So we do have to put the degree symbol from here on out if we're talking about degrees, but up to you whether you write. I'm going to write it here, but you don't have to. You can write rad or radians if you want to. And an example of this also, if you choose not to, would be if theta is equal to 2 and there's no degree symbol, we assume that it is 2 radians. All right, let's go in reverse, and then you'll be done for the day to go and practice. So if we want to go from radians to degrees, we'll take radians, and we're just going to flip that fraction. So now it'll be 180 degrees over pi. Note here that radians and radians here and here are going to cross cancel, and then we're going to be left with degrees in our final answer. That's why we can do this. So that's going to give us a degree answer. Let's convert for our example, negative 9 pi over 2. So we'll take negative 9 pi over 2, multiply by 180 over pi, and then watch the magic happen. So in this case, you should note here that the pi's will cancel out because there's one on the top and the bottom. We're multiplying across. You also can reduce the 180 divided by 2 and make that a 90. And then you simply have to multiply negative 9 by 90, giving you a negative 810 degrees. And again, you must have the degree symbol here. Otherwise, we would assume that we are in radians. So if you need more practice with this, again, one of those websites had additional conversion practice. You are going to take a look at pages 2 and 3 in your notes at this time. So you get some practice with it there, and then you do have the homework as well. As always, if you have questions, please reach out.